Last one for chapter 16. It says, what's the wavelength of the waves you create in a swimming pool if you splash your hand at a rate of 2 hertz and the waves propagate at 0.8 meters per second? So remember that a wavelength is like from the crest of one wave to the crest of another wave. All right, so this is actually wanting you to find the wavelength. Remember that wavelength has kind of a funny symbol. It's like this upside down Y. So we're going to solve for wavelength. And the wave's velocity is 0.8 divided by the frequency, which is 2 hertz, which a hertz is 1 over seconds. So whenever you do that, you end up with 0.4 meters. Okay, and remember your sig figs. This first one of chapter 17 is actually very similar to chapter 6 because it uses the same equation. It is saying what frequency sound has a 0.1 meter wavelength when the speed of sound is 340 meters per second. So this is the same equation, but now we're trying to find frequency. Okay, so we've got 340 meters per second divided by that wavelength of 0.1. And the frequency that we get is 3,400 hertz. Remember that frequency is measured in hertz. Okay, next one, we've got, oh, I'm definitely gonna have to put more spaces in here, sorry. This one is saying that a physicist at a fireworks display times the lag between seeing an explosion and hearing its sound and finds it to be 0.4 seconds. How far away is the explosion if the air temperature is 24 degrees? Okay, so let's see. Put my pen on again. All right, first off, what are we given in this? Well, we are given the time to be 0.4. Okay, why aren't you writing? 0.4 seconds. And it also gives us a temperature of 24 degrees Celsius. So if you remember, we had an equation that we could actually solve for the wave velocity by using this 331 meters per second times the square root of the temperature in Kelvin divided by 273 Kelvin. Well, how do you find temperature of Kelvin? You just take the temperature of Celsius plus 273. Okay, so then that's 24 degrees Celsius plus 273, which is equal to 297. So we have 331 times the square root of 297 divided by 273, which ends up giving you 345.24 meters per second. Okay, now that's not what it asks. It asks us to find how far. Well, why did I do that? Because velocity is equal to distance divided by time. And that's from a long time ago, right? So distance is equal to velocity times time. So we have 345.24 times 0.4 seconds, which ends up giving you about 138 meters. Okay? So hopefully that makes sense. Part B says to calculate the distance to the explosion, taking the speed of light into account. So does anyone know the speed of light just off the top of their head? Well, so I just want to write this equation again. Velocity is distance divided by time. This is wanting us to, again, calculate the distance to the explosion, taking the speed of light into consideration. So distance is velocity times time. Well, the velocity in this case is the speed of light, which speed of light is 3 times 10 to the 8th meters per second times that 0.4 seconds again, which is equal to around 138 meters. Hey, looky there. Same number. Okay? I'm wondering if I have enough space on this one. We can just see, huh? Okay. This next one says, what is the intensity in watts per meter squared of 85 decibel sound? Okay. So whenever you go to do this one, hold on, I'm gonna stop because I have another question from my daughter apparently, and then I will